All right, we're going to look at some algebraic properties. Um, we're going to give you names for some of these properties, and some of them you will use the name of them quite a bit, like the distributive property here. We're going to call it distributive property quite a bit. Some of the other properties we don't necessarily use their names, but we know how to use the properties, and we're going to come to that in a minute. But the distributive property means that you just distribute, or distribute means you like give things to everyone. Like if I was distributing papers in my class, I would give a paper to everybody in the class. So if I distribute this 3, I want to distribute it to everything that's inside of the parentheses. And so let's first off, we're going to distribute it to the x. So 3 times x is 3x. And distribute it to, what's this number? Pay attention to the sign in front of it. The sign is a -2. I know it looks like a subtraction if you are looking at it as x minus 2, but if you're only looking at that 2, that's a -2. So what is 3 times -2? That would be -6. Same thing on the next one. You go h times h. H times h, what's that? H squared. And then you do h times positive 10, which is a positive 10h. Now, if you look here at the third example, that 9 is on the right side when typically the h and the 3 were on the left side. But just because that 9 is on the right side, you still do distributive property the same way. The 9 gets put with everything inside. So 9 times 2j, well 9 times 2 is 18j. And then 9 times -5. You got to pay attention to the sign that's in front of it. 9 times -5, negative times a positive is a negative, and 5 times 9 is 45. And look at the last one. It's the same thing with t. T times 3 is 3t. And you notice I put the little leg down here at the bottom on the t, because if I didn't put it on the bottom, it could possibly look like a plus sign, and we don't want it to look like a plus sign. So t times 3 was 3t, and t times a positive 5t, it's a positive 5, and then t times t is t squared. And that is the distributive property. You take and distribute the number that's outside the parentheses with everything that's inside the parentheses. These ones are a little more in-depth for distributive property. Let me try the first one, you do the second one, and then I'll try the third one, and you try the fourth one. The first one here, x. I know it's not a binomial like we had before. Binomial is something like x minus 2. There's 2 terms in a binomial. This one's a trinomial. 1, 2, 3 terms in a trinomial. So we have this x times the trinomial, and you just multiply it by everything inside. X times x squared is x cubed. X times a positive 4x, well, that's a positive 4, and what is x times x in there? That would be x squared. And then now we go x times, you got it, that's a -2, and that would be a -2x. And you might wonder, when we have a variable with no number in front of it, there's no number in front of that h, right? Well, it has an invisible 1 in front of it, just like the x does. And that's the reason why when we took and multiplied this x by 4x, well, 1 times 4 gave us positive 4, and then x times x gave us the x squared. And that's how we can look at variables that don't have a number in front of them written there. It's an invisible 1. So now I want you to go ahead and try the second example. Pause the video and then play it and make sure your answer matches mine. H times h squared is h cubed. H times negative 3h is going to be negative 3h squared. And h times positive 10 is a positive 10h. All right, looking at the third example. The third example just has a negative sign out in front of the parentheses. And a lot of times you'll see it like maybe we'll have a number here, like we'll have a 3 there. And if that 3 is there, a lot of people get kind of confused about what you're supposed to do. But just like in front of the variables, there's an invisible 1. This negative sign separates the parentheses with an invisible 1. It's actually not negative with the parentheses there. It's a negative 1 times everything inside the parentheses. It's just that you should recognize that when you don't have a number there, it's a 1. And that's the same thing down here in the other one. You have a negative 1 down in the fourth example too. So how do we do this? We say negative 1 times 2j. What's negative 1 times positive 2? It's a negative 2, and then there's a j. And then we have negative 1 times negative 5. Got to pay attention to the sign that's in front of the number. A negative times a negative is a positive, and 1 times 5 is 5. You try the fourth example on your own. Pause the video and then play it and make sure your solution matches. So we have negative 1 times positive 3 is negative 3, and negative 1 times a positive 5t is a negative 5t. And that's what your solution should be. That negative sign out in front gets a little tricky sometimes. So we just got to pay attention to it. This is the commutative property. The commutative property, the order in which numbers are added or multiplied does not change the sum or the product. And you remember from the last lesson we did, sum means add and product means multiply. The commutative property only works for addition and multiplication. It does not work for subtraction and division. So, and it's kind of helpful. I mean, 4 plus 5, you know, is 9, and 5 plus 4 is also 9. That, you know, that's kind of simple and that makes sense. But if we look at something like this, you cannot say that this. You notice in the first one, real quick, numbers just kind of flip places, and that's what you think. Well, remember that this is a positive 4, so this plus sign has to show on the right side because we have it has to separate the 5 and the 4, and then this positive sign goes invisible because we don't need a positive sign, a leading positive sign. So if we look here in the second example, you have negative 2 plus 5. We can't switch those around, just the numbers. We can't say that's negative 5 plus 2. We can't do that. It's going to give us a wrong solution. Remember, it can only work with addition, so that's why when we do this, we have to put the negative number, the negative 2, in parentheses and make it a plus sign. And this positive sign is still here in front of the 5. It's just invisible. And 5 plus negative 2 is the same thing as 5 minus 2. When you add a negative, it's the same thing as subtracting. So that's real helpful. You have to pay attention that this negative sign has to either go with the 2 there or it has to go with the 2 there. You can't lose the negative sign or you can't put it with the 5. It has to go with the 2. For multiplication, it works the same. Remember, this is an asterisk, and it's just because I don't have a dot on my computer program to represent multiply, but sometimes you'll see asterisks represent multiplication. Once again, negative sign sticks with the 2. Okay. Why is the commutative property helpful? It's because if we look at the fourth or third example down here, you have 8 plus 6 plus 5 plus 7 plus 4 plus 3 plus 2. Well, there's an easy way to do that, and that's grouping things together. You can put 8 plus 2 together, and you can put 6 plus 4 together, and you could put a positive 7 and a positive 3 together, and then just have a 5 out here. 5's out all by itself. What's 8 plus 2? Well, that's 10. What's 6 plus 4? That's a positive 10. 7 plus 3, positive 10 again, and plus 5, and that's going to be 35. So it allows you to group numbers together that can be easily added. And that's the same way with multiplication. If we're all being multiplied here, let's look. We can take 5 and 4. 5 times 4 we know makes 20. We can then take a 15 and a 6. 15 times 6 is 60 and 30 make 90. And we can take a 10 times 10, which makes 100. And so now if we do this, and this should probably be able to be done quickly in your head, 2 times 9, that makes 18, and then times it by 1, which still makes 18, and we have 1, 2, 3, 4 zeros. So what we have here multiplies to get 180,000. Commutative property allows you to rearrange some things as long as you keep the negative sign with the negative numbers, and it only works with addition or subtraction. And this one here, remember, negative sign with the negative numbers. Just allows you to rearrange some things to make the addition or multiplication easier. The associative property is just the way you group the numbers, and once again, it's only for adding or multiplying. It does not change the sum or the product. So if we look here, order of operations, say we have 9, and then we say 2 plus 9, which makes 11. If we look on the right side, 2 plus 5 makes 7, add 4 to it, that makes 11, and those are equal. This is called the associative property. As long as you're always adding or multiplying, you can do this. 4 times 5 is 20, times by 2 will give you 40. 2 times 5 is 10, times by 4 will give you 40. Therefore, those are the same. It's going to be the associative property. The identity property just says you have the identity property of addition. It says if you add 0 to any number, you get that number. And you can add 0 to m and still get m. You can add 0 to, and if you notice, it looks like 0 plus 9x. It looks like you're adding 9x to 0, which you are, but you should also be thinking that you're adding that 0 to 9x. And I circled the wrong thing. Just make sure you realize you're adding that positive 0. You're adding 0 to positive 9x to get the same thing. And for multiplication, it's not multiplying by 0. It's multiplying by 1. When you multiply by 1, you get the same number you started with. You multiply by 1, you get the same number you started with. And it doesn't matter if it's 12f, you're still going to get 12f. Multiplied by 1, you still get 12f. That's the identity property. The property of 0 is, what do we have to do to get to 0? For addition, a property of 0 of addition, you have to take a number and its opposite. If you have a positive 5, its opposite number is negative 5. That makes 0. If you have negative 15, the opposite is positive 15. That makes 0. And you can even do it with variables. Positive x and negative x, you add those together, you get 0. Now with multiplication, you have to multiply by any number. You have to multiply it by 0. And therefore, you're going to get the 0. So it doesn't matter whether you are multiplying 12f times 0, you still get 0. Or whether you're multiplying negative x by 0, you get 0. Also works for numbers. It's a property of 0. This is the multiplication property of opposites. And remember, this only works for multiplication. It doesn't work for addition here. When you take what this is saying is, what you're going to do is you're going to have a number and multiply it by -1, and it gives you the opposite of the number you started with. So you have a number multiplied by -1, you get the opposite of the number you started with. Remember, you have -5, you multiply it by -1, and look at this. +5 is the opposite of the number you started with. It's going to be the multiplication property of opposites. Positive k, the opposite of positive k is a negative k, and you multiplied the positive k by -1 to get the opposite. I want you to pause the video. We'll make this 1, make this 2, make this 3, 4, 5, and 6. And I want you to name the property that makes the statement true. Remember, these properties, they're going to be like the commutative property of addition or the commutative property of multiplication. You're not just going to say the commutative property. You have to say whether it's of addition or of multiplication. So go ahead and pause the video there and write down the properties. All right, you should have the answers here. Let's go through these. Number 1, you should have the addition property of 0. The addition property of 0. Number 2, you should have the multiplication property of opposites. And you just listen for the last 4, and I will tell you what they are. Number 3 is going to be the identity property of addition. The identity property of addition, because you get what you started with. Number 4 is going to be the associative property of addition. The associative property of addition, because you are grouping, the way in which you group the numbers. It doesn't affect the outcome. Number 5 is going to be the multiplication property of 0, because when you multiply 8 by a number, you get 0, and that's the multiplication property of 0. And then number 6 is going to be the commutative property of multiplication. Commutative property means you just rearrange these numbers to get the right side of the equation. So that's all we have for algebraic properties. You should know what they are, know how to use them, and we're going to be using those for the rest of, actually you'll probably be using those for the rest of your mathematical career. Anytime you do math, you'll be using them. Thanks for tuning in to this lesson, and we will see you on the next one.